So I'm a bit of a coffee snob, and I love making espresso in the morning. Um, and there's a lot of math actually that goes into it, which is a little surprising. And so today we're going to be talking about the math that actually goes into it, which is proportion. So we'll talk a little bit about this, but the idea behind espresso is that you grind up your beans uh, fairly fine, and you want a certain amount of beans to a certain amount of volume that comes out of the espresso maker. So, for example, a typical ratio or a typical proportion of grind to volume of a liquid of coffee in the end is 1 to 2. So I want 2 grams of coffee, like brewed, for every 1 gram of coffee I grind and put through the espresso machine. And so that right there kind of creates what we call a proportion, and it allows you to kind of fiddle around a little bit with just the taste. You can make it a little bit more intense if you'd like, and do smaller than a 1 to 2 proportion. You could do 1 to 1.5. You could do a 1 to 3 if you want like a weaker kind of coffee. But that's the kind of idea with proportions again, and we're going to jump into this pretty heavily here, but the idea with proportions is that you can fiddle around with the ratio of certain things to get different results. And so I tend to like doing that with my coffee, making fancy lattes and all that kind of stuff. But in any case, let's go ahead and jump in. A proportion says that two ratios or two rates are equal to one another. For example, we have in this instance 3/4 is equal to 9/12, right? And so you can read them like a sentence: 3:4 as 9:12. I don't know if anyone watching this, or if you're in the course, if you've taken the SAT, but the SATs has in the verbal section, everything that they do in the verbal section is analogies. So it's like, this is to this as that is to that. And I remember as a student when I was in high school prepping for the SATs, I absolutely hated dealing with them, because I was like, your brain kind of shifts a little bit when you're like doing math to when you're doing like English related content. It's like, oh, I'm in an English class, so I need to be thinking about how things work in English. Or I'm in a math class and I need to think about how things work in math. But what I failed to realize is there was actually a lot of overlap between those. And analogies are nothing more than just mathematical proportions. How you look and relate them to one another is the important part. So the way the terminology that we use here is that the numbers that we read first and last are called the extremes, right? They kind of are the outside numbers, and the numbers you read in the middle are called the means, right? Typically, when you think of like the mean or the average is kind of like a middle number, and so that's a good way to remember it. The means are kind of the middle ones, the extremes are the ones on the outsides. So what we're going to do in a lot of these cases is we're going to use a process of cross multiplication to solve and determine. A lot of times there'll be missing variables. I have an example down here, but if we are trying to determine, say, if two proportions are equal, we will go ahead and cross multiply them. So if you think about it, we're taking the means, we multiply the means, and we multiply the extremes together. And as a result, we have a comparison. So 13 times 84, 36 times 29, we compare these two numbers. And as a result, you'll notice that these numbers are not the same. So this is a false proportion. These are not equal proportions because one ends up being larger than the other one. So we know automatically as a result of that, the original fractions are not equal to each other. The product of the means and the product of the extremes, it's like, so the process of cross multiplication, they need to equal each other if the proportions themselves are actually equal. Okay, so this is one of those examples where we have an unknown. And I will say this, there are so many instances where you use proportions all over the place, and it's not like, I just gave a kind of a silly example of coffee, right? Like trying to get the proper coffee brew. So like, for example, if I want a 1-to-2 ratio of espresso, and I know that the amount of coffee I have to put into my little basket is 19 grams of coffee, that means that I should, if I'm using a 1-to-2 proportion, twice 19 is 38. So I know that the volume that comes out should be 38 grams of liquid, right? If I want that ratio. Now, again, that's just a simple example, but there are multiple examples. When I know, like in the if you're cooking anything and you're sizing up your portion sizes, you have to use proportions to make sure that the amount of materials or the ingredients that you're putting in are matching the original proportion of ingredients, right? That's an example. If you're trying to calculate your hourly pay, right? You have a base salary, you try to calculate your hourly pay, that's a proportion. You could do it that way too. So these show up in all kinds of different possible cases. And so what I'm going to do, I want to show just a few different examples of how this specifically works. Let's just go ahead. I'm going to work on just some simple problems just to get us started. And then we'll have another kind of an actual like word problem. It's okay. So, So, there we go. Okay. I accidentally bumped my cable and one of my screens went dark. So, all right. So let's go ahead and do this problem. 3/8 is equal to x over 12. Okay. So anytime we have this is a little bit of algebra. Typically, we're not going to be doing a lot of algebra in this course because it's contemporary math, it's more practical stuff. But what we're going to do is we're going to take the means, the middle numbers, multiply them, the extremes, and multiply them. So again, we do cross multiplication when we have equal signs between two different fractions. So one fraction equaling another fraction, we can cross multiply them to determine what that missing variable is. And so as a result, what you're going to see here is that 8x is going to equal 12 times 3. Okay. So here we go, 8x. 12 times 3 is 36. I like 12s because I like thinking of like hours, 12 hours, 24 hours is a day, 36 hours is a day and a half, right? So again, just a way of making it practical. We'll go ahead and divide through by that number that's in front. So these two numbers are multiplying. And so in order to undo that, we have to divide. So we divide by that number. And so 36 divided by 8, this is going to produce 4.5. Okay. So that'll be the missing value. And that's it. All right, let's do another one. So this one we'll do 7/12 is equal to 25d. So here what we're going to do is again, same process, 7 times d. We'll do in this case, the extreme. This is an extreme, not a mean. The means are the ones that are the bottom here and the top here. The middle numbers, 7 to 12 as 25 is to d. So we do 7d is equal to 12 times 25. So again, this is going to be, you can think of this as days, right? or like a quarter, 12 quarters. That's the same thing as, oh my gosh, 300. There we go. This thing is incredibly sensitive. Just picking up all my hand touching. Okay, so now we do division. Divide both sides by 7. So D is going to end up equaling 42.9. Okay. Alrighty, let's go ahead and jump into the next one. This one's going to be a little different because we got decimals across the board. 2.8 is equal to, this is a B, by the way. I've had students in the past complain to me. They're like, your B's look like 6s. And then I point to my B and I say, seriously? Like, that doesn't look like a 6 at all. But all right, whatever you say, bro. 2.8 B. Thinking of somebody in particular who said that to me, and the dude was totally a bro. 1.2. So we've got our extremes here and our means in the middle. And so as a result, we have 2.8b is the same thing as 32 times 1.2 is going to be 38.4. My handwriting is so bad right now. 38.4. And we divide by 2.8. So B is going to end up being 13.7. Again, this is all calculator work at this point. And I'm not going to bore you with the details of me just kind of punching away on my phone. Like in previous episodes, classes, I don't know. Okay, this is a real fun one. The ratio of the weight on the moon to the Earth. Ratio of weight on the moon, Earth, going to be 1 to 6. Okay. So that means that a person weighs 6 times less on the moon than they do on the Earth, or 6 times more on the Earth than they do on the moon. So how much would a 174-pound person weigh on the moon? All the important questions we have to address here. So what we have, again, remember, proportions like this or ratios like this can be written as fractions. So this is going to be 1/6. And I know the weight of the person on the Earth. And we do not have the weight of the person on the moon. So we have this proportion now. And so what we can do is go ahead and follow the process that we did above and work through this. So this is going to be 6 times x is equal to 174 times 1. Just 174, I guess. Divide through both sides by 6. And what we're going to end up with is x is equal to 29. And this is going to be in terms of pounds. Okay. So a person who weighs 174 pounds on the Earth should weigh 29 pounds on the moon. There you go. Good weight loss program. Just go to the moon. All right. Here's another one. Actually, this one's pretty beneficial. One of the things that I do on the side, I do a number of things, actually. I do photography on the side. I do some audio engineering, and the church that I currently serve at, I play bass as well, a bass player. So the church that I play bass there. We're going through a pretty substantial building expansion, and at the time of this recording, there are architectural plans that have a scale associated with them, right? And so this question is very similar to that, because you have to figure out what the true size of something is based upon architectural plans that have, obviously, the whole thing scaled down. So the scale of an architectural is 1 inch equals 3 feet. Find the length and width. Of a room that measures 5 inches by 8 inches. Okay. On the drawing, I should say. That one's kind of a given. Okay. So there's actually 2 parts to this. It's not just find a single unit because we need length and width, right? So for the length, what do we have? We've got 1 inch is 3 feet. Okay. 1 inch is 3 feet. And for length, I usually go with the bigger number, but that's fine. So 8 inches is to my unknown, call it X. So let's go ahead and solve that. X times 1 is equal to 3 times 8. So X is equal to 24. And this is going to be feet. Okay, so that's the length. Now we have to do the width. So the proportion is the same, right, for the original, or the ratio, I should say, is the same for the original, what was given, right? 1 inch is always going to equal 3 feet in these dimensions. And so we just have to compute the other missing piece, which is the 5 inches. So in this instance, I'm matching these up. So this is 1 inch, this is feet, this is inch, this is feet. Okay, so make sure if you're doing or setting these proportions up, you actually are matching the appropriate units together. You cannot be mixing and matching units. So as a result, I've got X is equal to 5 times 3. So X is in this case equal to 15 feet. So the dimensions, the room, 24 feet, 15 feet. Okay. And that's pretty much it. That's all we have for this section of content. Again, a lot of these videos will probably be on the shorter side, just going through a few examples. I don't want to bore people with these massively long videos. So some of them might be longer as we go further through the course, more complicated stuff. But if you have any questions, feel free to let me know. Enjoy.